那我先跟你说吧。Hello everyone, this is Zidu, and this is Zhao Tianlu. We're in team 14, and this is our final project, the optimal stock prediction.
So what we are using is the Farmer-French three-factor model. The model actually identified the risks of stocks as driven off the stock returns. So the first risk is the market risk premium. And the second risk is about the company size. We identified a small company has larger risk, so it will generate higher return. The third risk is the book value divided by market value of the company. If the company has very high book value divided by the market value, then we identify it as a high risk company, so it will also generate higher return. So our project is about optimization of stock prediction for our stakeholders listed as individual investors, institutional investors, and potential financial learners. And our key question is about which stock to invest, what is the expected return, and how likely it will be, and what are the risks involved in investing these stocks. And we use multiple ways to predict the future returns of each individual stocks. And we also use some metrics to identify risk in investing these stocks. So our idea goal is about stock return prediction and offer investors information about each stock. So we identify some key factors. The first key factor is about the historical performance of each stock. The second is the growth trend of stock itself. The third one is the growth trend that is analyzed by the three risks we identified before, and also the likelihood of the return that will generate. We have a dashboard interface that uses multiple ways to predict future returns with a real-time analysis. And our final goal is to generate models for prediction of returns for individual stocks and the risk associated with these models. So about our model, the functions can be actually divided by three parts. The first part is about the explore of data. It shows all the historical performance of individual stock. Then it's about the predictions and the stats. The prediction, we use actually three models. One model is the ARIMA forecast. The other model is the linear regression of the Farmer-French three factors. And the third model is the moving average forecast by Farmer-French three factors. And each model have different purpose. The ARIMA model is identify the growth trend of stock itself. The regression model is to tend to find the relationship between the growth of stock and by the risk factors. And the moving average forecast is to identify whether there are seasonalities in those stocks. And we also have some stats shown. It's the correlation matrix and the prediction versus the actual return use our models that generated. And the third part is about the optimization. The optimization part, we have actually included two machine learning models from Carrot. One is the machine learning linear regression model, one is the Earth model. And we also include an H2O random tree model. These models are for the comparison and to give investors information about whether there are other models that they can use to generate more precise predictions.
Thank you. So this is our Shiny app, and we separated it to several different tabs. And for each tab, it has its own function. And for the first tab, is explore data. You can put any kind of a stock, but for easy, I just set it as Amazon, but you can change it to anyone. And then you can put a date range. The range could be various. And then here's what the technical statistics you want to show, and then just click update. We twisted a little bit of this. So it to make it looks better, and we change this stock, this tab, so that you can choose any stock you want. Yeah, basically, as long as it's on the database. The database we use is Yahoo Finance, and then here's the important part. For here, it shows error because you haven't clicked the update. Same before, you can choose any stock you want, and here is JP Morgan. There's date range. I set it up the date range for the maximum of the August 30th. It's just because like we use the Farmer-French model as basic, and the data we have for Farmer-French model is not updating as fast as the daily stock value, so we have to set a maximum, and maximum is 30th. So we can choose anything before that, anything, just give it a range. And then here's the forecast period. Forecast period would affect the ARMA model, and also the carry model. This is an important factor, and the confidence interval would affect the ARMA model again also on this one. And then we just click the update. So here's all we got.
So about the picture shown in the right is the actual return of the stock versus the prediction using the linear model that we identified by the Farmer-French three factors. and we can see the predictions and the actual values are very close. So it means that we may have a very close prediction to the actual returns. And if we scroll down, we can see all the stats that are generated by the linear model. And the estimates of SMB, HRM, and the Masquerade premium generated, you can actually use these data to generate further predictions if you have the Fama-French three-factor data. And we can also see the p-values, and the p-values are pretty small, so it suggests that they are highly correlated in predicting the returns of a stock. And we also can see the adjusted R-square is about 0.8, so suggests that the model can have about 80% accuracy in generate returns.
Yes. So this is our second tab. And then it's our ARIMA model. So here's our ARIMA forecast. For ARIMA forecast, we used our forecast period before, and then we generated this forecast graph in minutes. This is the time we have. And also, we have a correlation map. The bigger the dot you can see means that this variable would have a higher correlation or would make a higher contribution for the regression.
So here is our model of a moving average with Fama-French three factors. And you can see the purple message box will generate the average R-square, adjusted R-square, using the Fama-French three factors moving average model. The moving average days is the days that you plug in the linear prediction model. So we can see that for this stock, it have about 70% accuracy. That is actually very good. So we have a good sign shown here. So if the accuracy of the model is between 50% to 17%, then we will generate okay. If it's below 50%, then we will generate try again. And of the picture below, we can see there is a rolling adjusted R-square using the moving average with Fama-French three factors. And we can see that the accuracy is varying from different time. And also the beta of this model is varying. So if we scroll down a little bit, we can see that there is a table. The table, there is the estimate that we can use these data to generate further prediction if you find the moving average model is actually better. And we can also see the p-value of all these stats to see whether it generates a good prediction.
So this is our H2O tab. We use the random forest to do this calculation. You can see there's all those statistics. The client can use this tab to let the H2O machine learning to give them idea about how good this model is. So in here, I want to specify that we only use one model, but actually can use more since the Shiny app got pretty low memory base, which means it's going to take lots of time if you put a lot of different model in it. And so I would suggest that if you guys want to use this, if the client want to use this, they would better to download our code and run in their personal computer. That's what I think. But definitely you can add more model in it, and it's pretty easy. So here's our machine learning models by the Carrot. We only use 2 models in this graph, but basically you can put like 5 or 10 or more models in it, as long as you already have it. But the reason why we only put 2 is the Shiny apps got very low memory base. For this tab only, it runs about like 2 to 3 minutes to just complete these 2 models. I know it's pretty bad, but if you guys want to try feel the true powerful meaning of our application, you can definitely download it from the GitHub and run it from your personal computer or RStudio, and it will be great. It's pretty weird because if you run it in your RStudio, it will never be that slow, and it won't crash. In Shiny app, if two or more people using this app simultaneously, this app gonna crash randomly. For the specific graph, you can see for the y-axis is a different model you run, and for the x-axis is a R-squared for 2 different models. And those interval is just the confidence level of 95%. At this page, you can clearly see like which model is better in this aspect. If you compare various model, it can just give you various models data simultaneously and with visualized output. I think this is pretty good. Finally, here is our references. You guys can check it out if you have any interest in it.